Namaskar, I am Anand and you are in the live class of Join for Education. Let's discuss about sets, relations and function. These are the learning point, sets, Venn diagram, operations on set, law of algebra, Cartesian product of sets, relations, composition of relations, functions or mapping, composition of function. Let's discuss one by one. So let's see the details of the set. A set is a well-defined class or collection of the object. Set are usually denoted by the symbol ABC and its elements are denoted by a small ABC, etc. If A is an element of a set A, then we write A and this is a Greek symbol and name of this Greek symbol is upsell or a small Greek alphabet. This one is known as the upsell. So A is an element of set A, and if not, then we write a strike upsell A, and A is not an element of A. We have two methods to represent a set. First one is known as the roster method. Other name of the roster is tabular and also listing. In Hindi, this one is known as the Sharnividhi. The second method to represent a set is set builder method. Other name of the set builder is ruled method. So in roster method, a set is described by listing elements separated by commas within curly braces. This is the curly braces or curly. Other name of the curly braces is middle bracket. A set of vowels of English alphabet may be described as A, E, I, O, U within curly braces or middle bracket. In set builder method, other name of the set builder is rule method. A set is described by property which is possible by all its elements acts. In such a case, the set is written as X is the element of set such that Px is the property of the element. So we represent the set in set builder method. Other form to set builder method, instead of column we write a vertical line and we read as X is the element of the set such that Px or hold the property of the element which is read as the set of all X such that property of the element holds. The set P 0 1 4 9 16 dot dot can be written as x square, where x is the element of or belongs to whole number. So after there is no problem to understand the Details about the representation of set. We have two methods to represent a set. First one is known as the roster. Other name of the roster is tabular or listing. Second method, which is used to represent a set, is the shade builder. Other name of the set builder is rule method. Now see the types of sets. This is also one most important subtopics of sets relation and function. So null set as per the number of elements present in the set. So null set is also, or other name of the null set is empty set, void set. The set in which number of element is zero is known as the null set, and it is denoted by the Greek alphabet phi, or we write only middle brackets without any element. And if it contains a single element, then it is called singleton set. If anybody asks us what do you mean by empty set, null set, or void set, the set in which number of element is zero is known as the null, empty, or void set. The number of element in a set is one, then we say this is the singleton set. A set in which the process of counting of element definitely comes to an end is called finite set. Or in other words, the set whose elements can be counted is known as the finite set. The set whose element cannot be counted is known as the infinite sets. Now discuss about equal set. In equal set, two or more than two elements have exactly same elements. Then we say two or these two more elements are the equal set. Here A, B are said to be equal set if every element of A is an element of B. Also every element of B is an element of A. So A equal to B if X is the element of A, then X is also the element of B. However, there is no problem to understand the non-empty or void set, singleton set, finite set, infinite sets, equal sets. Let's progress the colors. Let's see the equivalent set. Equivalent set have exactly same elements. If two sets have exactly same elements, then we say this is the equivalent set. Let's see the universal set. A set that contains all sets in a given context is called universal set. It is generally denoted by capital alphabet U. Let's see the subset. Let A and B be two sets. If every element of A is an element of B, then A is called the subset of B. In mathematically, it is denoted by this one. A is the subset of B. It means that every element of A is an element of B. Let's see the proper subset. If A is a subset of B and A not equal to B, then A is a proper subset of B, and mathematically this one can be written in this way. A is the subset of B. A is the proper subset of B. A is the subset of B. It means that A and B are not equal, and as per the property of subset, every element of A is present in B. So hope that there is no problem to understand subset, proper subset. Let's discuss about improper subset. Null empty void set is a subset of every set, and every set is subset of itself. So these two are also known as the extreme set, and this extreme set is the improper subset. So proper and improper subset. Improper subset is the itself as well as it is the null empty or void set. We know that null empty or void set is generally denoted by Greek alphabet phi. So all improper subset can be subset or subset. All proper subset are the subset, but all subsets are not the proper subset. All subsets are not the improper subset. After there is no problem to understand subset, proper subset, mathematical denotion of the proper subset, and improper subset. Let's see the power set. If S is any set, then the set of all the subset of S is called the proper subset of S, and it is denoted by PS, or we read this one as power set of A. Given set is always non-empty. Power set of a given set is always non-empty set. It means that for empty set, we have problem to find out the power set. If A has an element, then power set of A has 2 to the power n element. After there is no problem to understand the details up to this step. So here is a note. Let's see the note. The set phi is not a null set. It is a set containing one element phi. If we consider about this one, so the element is, this is a singleton set. This set is one element which is phi. So we do not say or cannot say this is a null empty void or phi. So it means that this is not the empty set. Let's see. Whenever we have to show that two sets A and B are equal, then we saw that this is the A is the what? A is the, let's see here, A is the subset of B and B is the subset of A. In that case, we say A and B are equal. If A is the subset of B and B is the subset of A, then sets A and B are equal. It means that have same number of elements. It means that, let's see, if a set A has m element, then the number of m is called cardinal number. If anybody asks us what is the cardinal number, then the number of element of a set is known as the cardinal number, of denoted by Na. Cardinal number of a set equal to m. Here m is the number of elements. Now discuss about Venn diagram. Ben Euler had an outstanding contribution in the field of shape. For the regard of his name, a topic has been naming on his name, which is Venn diagram. In Venn diagram, we consider about two geometrical figures. First one is the rectangle, other is the circle. Circle is inside the rectangle. Rectangle denote the universal shape, and circle inside the rectangle is the shape. Let's discuss about operation on shape. Just like operation in mathematics, we consider about addition, subtraction, multiplication, and division. Similarly, operation on sets, generally we consider about union, intersection, complement, difference, and symmetric difference. Let's discuss one by one. Union is a kind of operation on set. So the union of sets A and B is the set of all elements which are in set A or in B or in both A and B. A union B is generally denoted by this symbol, and this one is written in the set builder form. So X is the element of A union B such that X is the element of A or X is the element of B. The graphical representation of union of two sets is just like this one. So hope that there is no problem to understand union of sets A and B or union of two sets. Let's see the intersection. So the intersection of A and B is the set of all those elements that belongs to both A and B. It means that intersection, it means that it is a kind of set and generally denoted by this one. And we read A intersection B is a set whose element or whose all common elements of A and B. Let's see the Venn diagram of this one, and set builder representation of A intersection B. This is the A intersection B. X is the element of A intersection B such that X is the element of A and X is the element of B. Instead of and, if we write down or, then intersection will be A union B. And this is the graphical representation of A intersection B. So we said it all common elements of A and B. This is the universal set, and A and B are the set. Of that there is no problem to understand up to this step. If the intersection of two set is the phi, then we say both A and B are the disjoint sets. If anybody asks us what do you mean by disjoint sets, if A intersection B is a empty, void, or null set, then we say that both A and B are the disjoint sets. Of that there is no problem to understand disjoint set. Let's discuss about complement of A. Let U be an universal set and A be a set which such that A is the what? This is the proper subset of universal set. Then complement of A with respect to U is denoted by A dash AC or U minus A. It is denoted by the set of all those elements of U which are in A. And let's see, we find out U minus A is the complement of A. It is generally denoted by this one, this one. So these are the notion which is used to denote the complement of set A. So here complement of set A, this one, and we shaded the all portion of rectangle except circle portion. So this one indicate that what intersection of two set. Observe there is no problem to understand up to this set. Let's see the difference of the set A and B. Is the set of all those elements of A which does not belong to B. Let's see the A minus B. It means that this is the universal set rectangle and these are two sets. Here A minus B, it means that we shaded uh, remaining part of the circle A, and we read as A minus B, B minus A. So we read as X is the element of A minus B such that X is the element of A and X is not the element of B. It means that this is the and for and we write down intersection A intersection complement of B equal to A minus B. However, there is no problem to understand difference of sets. Let's discuss about symmetric difference of set. For this, we put at a glance in this figure the symmetric difference of set A and B is the set A minus B union B minus A and is denoted by A capital del plus B. So, graphical representation or Venn Euler diagram is this one. Now discuss about law of algebra of set. In the law of algebra of three set ABC, it important laws A union A equal to A intersection A equal to A union phi equal to A and A intersection U equal to A. Distributive law A union B intersection C equal to, we write down A union B intersection this one A union C. A intersection B union C equal to A intersection B union A intersection C. Observe there is no problem to understand idempotent laws, identity law and distributive law. Let's see the next subtopic of this one, which is the De Morgan's law. Yeah, in De Morgan's law, complement of A union B equal to complement of A intersection complement of B. Let's see here. Complement of A intersection B equal to complement of A union complement of B. Let's see next property of De Morgan law, which is A minus B intersection C equal to A minus B for intersection. We write down union A minus C. 6. A minus B union C equal to A minus B. This is the intersection A minus C. So these are what? Then these are the difference of set A and union of B and C. Let's see the associative law. In associative law, A union B, union C, we make the pair of two, then A union C or A union B union C. All are the here union. Here A intersection within B intersection C. So this one we write down A union B union C. Observe there is no problem to understand up to this step. So here are some formula. This formula will be used during the solution of the exercise problems related to the sets, relations and functions. Let's see here relations. Let's clear the basic concept of relation. For this we have proper idea about set. If we have proper idea about set, then we have no problem to understand relation. Let A and B be two non-empty set, then relation B from A to B is a subset of A cross B. So the R is the subset of A cross B. Of that there is no problem to understand. In mathematically, this one denoted by this one. R is the subset of A cross B. It means that we have proper idea about the Cartesian product of two sets, then we have no problem to understand this one. So now discuss about types of relation. In types of relation, let's see. Let A and B any non-empty set, then R be relation on A. Then R is said to be reflexive. These are the types of the relation. If ordered pair A is the element of R for all A is the element of A. R is said to be symmetric if AB is the element of R and BA is also the element of R for all A and B, then we say this is the symmetric relation. Let's see the transitive relation. R is said to be transitive if AB is the element of R and BC is the element of R, then AC will be the element of R for all ABC. So A is related to B, B is related to C, and here ABC is the element of R. Let's see the relation IA. AA is the element of IA such that A is the element of A. On A is called the identity relation. In that case, we say the identity relation on A. R is said to be equivalence relation if it is reflexive, symmetric, and transitive. So, set or relation which is reflexive, symmetric, transitive, then we say this is an equivalence relation. Let's see here. AB is the element of R, BC is the element of R, and if we get AC is also the element R for all ABC, then we say that this is an equivalence relation. Let's take a little idea about inverse relation. Let R be a relation from set A to set B, then the inverse of R denoted by R to the power minus 1 and is defined by AB is the element of inverse set if such that AB is the element of relation. Clearly, AB is the element of R and BA is the element of inverse of the relation. Of that there is no problem to understand up to this step. Let's discuss about the notes. The intersection of two equivalence relations on a set is an equivalent relation on the set. Of that there is no problem to understand up to this step. The union of two equivalence relations on a set is not necessarily an equivalence relation on set A. If R is an equivalence relation on a set A, then inverse relation R is also an equivalence relation. After there is no problem to understand up to this step. Let's see the composition of relation. These mathematical symbols denote the composition of relation. Let's see. Let R and S be two relations, set A to set B and B to C respectively. Then we can define a relation so R from A to C such that AC is the element of composition of S and R and B is the element of B such that AB is the element of R, BC is the element of S. This relation is called the composition of R and S. Observe there is no problem to understand up to this step. In the next class, we shall discuss about function or mapping. In the next class, we discuss about function or mapping. Let's see some examples or exercise problem of relation functions and this is the foundation question exercise. Let's see, this one is written in the set builder form. X is the element of Q such that x equal to 1 by y, where n is the y is the element of natural number. So if we write down here Q is 0 is not the elements of Q because 0 is not a rational number. So let's see here, when we put y equal to 1, then we get x equal to 1 by 1 equal to 1. So this is what, this is the correct option of this question. Observe there is no problem to understand or pick out the correct option of question number 1. Let's see the next question. PA, it means that power set of A denotes the power set of A and A is the void set. Then what is the number of element in power set of power set of power set of power set of A? It means that it will be 0. Observe there is no problem to understand the correct option of question number 2. Let's see the question number 3. This is the question number 3. For to the power n minus 3 n minus 1 is the element of x such that n is the element of natural number and y equal to 9 whole star n minus 1 is the element of y such that n is the element of natural number where n is the set of natural number. Then x union y is equal to, let's see the correct option of this one will be y. So sorry, the correct option of this one will be y. Of that there is no problem to pick out the correct option of this question. This question is asked in JEE Maths 2014. Let's see the question number 4. If A, B, C are three sets such that A intersection B equal to A intersection of C. So these two are the equivalence relation and A union B equal to A union C. Then the correct option of this question will be B equal to C. Of that there is no problem to pick out the correct option of this question. Let's see the question number 5. Suppose A1, A2, A30 are 30 sets each having 5 elements. B1, B2 up to Bn are n sets each having 3 elements. Therefore, union of 1 to 30 A1 equal to universal set of Bj from 1 to n equal to S and each element of S belongs to exactly 10 of complement of A and exactly 9 of complement of B. The value of n is equal to. Already we have discussed about the number of element of a set. So the correct option or correct answer of the question number 5 will be 45. So the correct option of question number 5 will be C. Of that there is no problem to understand the solution of this question. Let's see question number the rest question I will solve in the next class. Till then, thanks to all of you. Thank you very much.